Hello everyone. So in this video, we'll talk about statistical measures of asset returns. If you are new to the channel, please subscribe it and share this video so that other candidates can also benefit from it. In the description box, I have dropped a link for this presentation. You can download the presentation. It will work as quick revision notes for you in the last phase of your preparation. Also, I have dropped a link to the Telegram group. You can share your doubts in the Telegram group and I will make sure to solve these doubts. Let's move ahead. There are 4 learning outcome statements in this module. Calculate, interpret and evaluate measures of central tendency and location to address an investment problem. A measure of central tendency specifies where the data are centered. So there are 4 different types of measures. First one is arithmetic mean. The arithmetic mean is the sum of all the values of the observations divided by the number of observations. So this is a simple arithmetic average of the data set. The second one is sample mean. The sample mean is the arithmetic mean computed from a sample. Now, what is the difference between the sample mean and the arithmetic mean? Sample mean refers to a particular sample of the universe, but arithmetic mean means the mean of all the values in the universe. Suppose you are an investor, so all the securities listed on the stock exchange are your investment universe. You can divide this universe into different samples. Like if you want to only concentrate on the large cap securities, then that will become your sample. The median. The median is the value of the middle item of the data set. The middle item of the data set that is sorted in ascending or descending order. So for odd number of observations, the median is the value of n plus 1 divided by 2 position. For example, for 5 observations, the median is the value of third position. Suppose you have got 5 values. So your median will be the central value, the third position value. And if you have an even number of observations, suppose you have 6 values, in that case, your median will be the average of these two central values. So your median will be the average value of n by 2 and n plus 2 by 2 position. The mode. The mode is the most frequently occurring value in a dataset. The dataset can be unimodal consisting of one mode, bimodal consisting of two modes, or it could be the case that there is no mode at all because all the items are distinct. There is no such item that is occurring more than the other items. Now let's see how we can deal with outliers. We have 3 options. First is do nothing, use the data as it is, but it will create problem for you. Suppose your data is all your data is lying from like 5% to 20%, but there is an outlier which has the value of 60%. So if you include that 60% value into your data set to compute the averages, your averages will be biased upwards. So this option is not a valid option, not a good option for the investors. The second is delete all the outliers. That means you exclude the item from the dataset itself. So that means you exclude the 60% item from your dataset. That will result in a trimmed mean. And the third option is you can replace the outliers with the nearest value. Suppose your data is from 5% to 20% and you also have a 60% value. So you will replace that 60% with the nearest value of 20%. So that will become your vinsorized mean. I have discussed trimmed mean and vinsorized mean in the rates and returns reading, so you can check that video. Now let's discuss the measures of location. Location means you want to specify where a particular item is located in your dataset. So we divide the complete dataset into different parts. First of all, let's discuss quartiles. Quartiles, it divides the data into quarters. Suppose this is your complete data and you can divide into different quarters. So these are your 4 quarters: first quarter, second quarter, third quarter and fourth quarter. and then you can specify whether your data is lying in the first quarter, second quarter, or third quarter. Quantiles. Quantiles divides the data into fifths. So there are 5 quantiles in a data set. You divide the data into 5 equal quantiles and then specify where your data is lying, in which quantile your data is lying. Deciles. In deciles, you divide the data into tenths. So there are 10 equal deciles in the data set. Percentiles. In this case, you divide the data into hundreds. So there are 100 percentiles in a data set. Now let's discuss IQR, that is interquartile range. Interquartile range is the difference between third quartile and the first quartile. That means from this to this is your IQR. So basically IQR is the values lying from the lower part of the second quarter to higher part of the third quarter. So that is your interquartile range. This is also shown through the box and whisker plot that is shown here. So this is the box and whisker plot. In this is your highest value of the data set and this is your lowest value of the data set. This box here is your interquartile range. Your quarter 2 starts from here and quarter 3 ends here. So this is your interquartile range, the lower boundary for quartile 2 and the upper boundary for quartile 3. This line represents the median of the database and the X here represents the mean of the database. Calculate, interpret and evaluate measures of dispersion to address an investment problem. So dispersion means that how your data is spaced in the universe. Absolute dispersion is the amount of variability present without comparison to any reference point or benchmark. That means you are not comparing the dispersion with any benchmark. So there are different measures of absolute dispersion. The first is range. Range is the difference between the maximum and minimum value of the data set. So that will become your range. Mean absolute deviation. In mean absolute deviation, you want to check that how much dispersed values are with respect to the mean of the data set. So you calculate the average value, the mean of the data set, that is represented here by X bar, and then you calculate the difference of each value from the mean and take its absolute value. Suppose the values are equally dispersed around the mean, that means some values are below the mean, some values are above the mean, and when you sum their values, the difference could result in the sum could result in a value of 0. So that's why you take the absolute values, because you are concerned with the dispersion of the values. So you take the absolute values of the difference and then sum all the values and divide by n. So that is your mean absolute deviation around the mean. Now let's discuss sample variance. Variance is defined as the average of the squared deviations around the mean. So similarly, you calculate the deviation of values from the mean and then square it, add all those values and divide it by n minus 1. So that will become your sample variance. Sample standard deviation. Sample standard deviation is simply the square root of the variance. So you calculate the variance and then take the square root of the variance, that will become your standard deviation. Target semi-deviation. Target semi-deviation is a measure of dispersion of the observations that are below a target. Suppose you want a target rate of return of 5%. So you are concerned with values that are below 5%. If sometimes you get a return more than 5%, that is not a concern for you. But you are only concerned when the return earned is less than 5%. So what you do is you calculate the deviation of all the values that are below the target value. That means for all xi less than target, you take their square and then sum it and divide it by n minus 1. So that will be your target semi deviation. Now let's discuss relative dispersion. When we are dealing with different data sets, relative dispersion is more useful than absolute dispersion. Relative dispersion means how each data set is dispersed as compared to the other data set. Let's discuss the coefficient of variation. Coefficient of variation is simply the ratio of standard deviation of a set of observations to their mean value. So you divide the standard deviation computed by the mean value of the data set, and that will become your coefficient of variation. The higher the coefficient of variation, that means your data set is highly dispersed. Interpret and evaluate measures of skewness and kurtosis to address an investment problem. First of all, let's discuss the normal distribution. A normal distribution as represented here is such that 50% dataset lies on the right side of zero standard deviation and 50% data lies on the left side of the zero standard deviation. But in reality, there could be some scenarios in which data lies on a particular side, or on the positive side or on the negative side. That is known as skewness. A return distribution with positive skew, this is the positively skewed distribution, has frequent small losses. Your losses will be more but of lower magnitude, and a few extreme gains. Your gains will be lesser than your losses, but the magnitude of gains will be higher than the magnitude of losses. And in a negatively skewed distribution, the case is opposite. In this case, you have frequent small gains. Your gains are frequent, you have a higher number of gains but of smaller magnitude, and a few extreme losses. Your losses are lesser but your losses are of high magnitude. So that is called as skewness. Now let's see how we can calculate the skewness. Skewness is calculated using this formula. First of all, we calculate the dispersion of values from the mean and then cube it and sum all these values divided by the standard deviation cubed times 1 by n. N is the number of observations. This formula is only applicable when n is larger, that is 100 or more observations are required. Now let's discuss kurtosis. Kurtosis is a measure of combined weight of tails of the distribution relative to the rest of the distribution. Here, this one is your normal distribution. This is also called as mesokurtic. This is a normal distribution. It is also known as mesokurtic. It has a kurtosis of 3. So we compare the return distributions with normal distribution to check whether they have excess kurtosis or not. So first let's discuss the leptokurtic distribution. A leptokurtic distribution has fatter tails. As you can see, this is the leptokurtic distribution. It has more weight in the tails than the mesokurtic distribution. So that means its excess kurtosis is above 0 and its kurtosis is greater than 3. So it has fatter tail than the normal distribution. It is known as leptokurtic. And if the tails have lesser weight, than normal distribution, they are known as platykurtic distribution. As seen here, see, this is the tail of platykurtic distribution. It has lower weight than the normal distribution, so it is a thinner tailed distribution as compared to the normal distribution. Its kurtosis is less than 3 and its excess kurtosis is less than 0. It is known as platykurtic distribution. This is the formula to calculate the kurtosis, excess kurtosis, because we are subtracting 3 here. So this is the formula for excess kurtosis. Interpret correlation between two variables to address an investment problem. First of all, let's discuss a scatter plot. A scatter plot is a useful tool for displaying and understanding potential relationships between two variables. Let's see, we have two variables x and y, and if the graph of x and y goes like this, that means there is a positive correlation. As x is growing, so is y. And if the graph is like this, it has a negative correlation, because as x is growing, y is decreasing. In the third case, we have a scattered graph. In this case, there is no particular correlation between x and y. Correlation is a measure of linear relationship between two random variables. The first step in considering how two variables vary together is constructing their covariance. First of all, let's calculate the sample covariance. Sample covariance is Sxy. It is a measure of how two variables in a sample move together. This is the formula to calculate the sample covariance. We calculate the dispersion of each observation from x bar and the dispersion of each observation in the y dataset from y bar, then multiply them together and add all these together, divided by n minus 1. So that will be your sample covariance. The sample correlation coefficient is a standardized measure of how two variables in a sample move together. First of all, you calculate the sample covariance. From sample covariance, you calculate the sample correlation coefficient. Sample correlation coefficient is the ratio of sample covariance to the product of two variables standard deviations. So correlation coefficient is equal to sample covariance of xy divided by standard deviation of x times standard deviation of y. The correlation coefficient expresses the strength of the linear relationship between two random variables. There are some properties of the correlation. The correlation ranges from -1 for negative correlation to +1 for positive correlation. So the correlation coefficient will always lie between -1 and +1. A correlation of 0, termed as uncorrelated, indicates an absence of any linear relationship between the variables. A positive correlation close to +1 indicates a strong positive linear relationship. A correlation of 1 indicates a perfect linear relationship. Similarly, a negative correlation close to -1 indicates a strong negative linear relationship. A correlation of -1 indicates a perfect inverse relationship. There are some limitations of correlation analysis. First is, correlation may also be an unreliable measure when outliers are present in one or both variables. So if one or both variables contains outliers, that will bias your mean calculations, and if your mean calculations are biased, your correlation coefficient will be an unreliable measure. Also, correlation does not imply causation. That means if x and y are correlated, you cannot say that x causes y, and you also cannot say that y causes x. Even if two variables are highly correlated, one does not necessarily cause the other. It could be the case that there is a third random variable, let's say b, which causes both x and y. In this case also, x and y will be highly correlated, but x does not cause y and y does not cause x. So you need to be careful when you are interpreting the meaning of correlation. So that's it for this module. If you have any doubts in the video or any doubts related to the level 1 curriculum, please share your doubts in the Telegram group. I will try my best to solve these doubts as soon as possible. Also, please like the video and subscribe the channel so that you can get notified on the next videos. Thank you very much.